In example 6.9, we are asked to define a linear function that passes through negative 6, 4. That'll be our first condition, and is going to be perpendicular to the line that has an x-intercept of 2 and a y-intercept of negative 4. So this is different than examples 6.8 and 6.7 in the fact that we don't have an equation provided within that second condition. So I have to think about these as ordered pair. X-intercept would be the ordered pair 2, 0. The y-intercept would be the ordered pair 0, negative 4. And if I want to think about the line that's being created by these 2 points, I have a blank grid here, so I'll mark a point for the x-intercept, mark a point for the y-intercept, and then I can draw a line that, I'm going to try to make it a little straighter than that. And there it is. That's not too bad. So that would be the line that we're supposed to be perpendicular to. And then for our function definition, we have to make sure that we pass through the point at negative 6, 4. That's the first condition. So let me estimate about where I think this is going to be. So if I draw a line through that point that's going to be perpendicular, it's going to look about like this. This is just an estimate. This is not what the final line is going to look like. But what it does is it gives me a perspective on how the slope should look approximately in the coordinate plane. Since we're dealing with a linear function, we know that the equation has to be of the form y equals mx plus b. I have to have the slope and I have to have the y-intercept. The slope is going to be connected to the slope of the red line. So I need to figure out the slope of the red line. There's 2 ways to do that. There's the algebraic approach, which uses m equals y2 minus y1 over x2 minus x1. And if I use the x-intercept and y-intercept points, that's going to be negative 4 minus 0 divided by 0 minus 2. Simplify to get negative 4 over negative 2. That will reduce to 2 over 1. And we typically would just write that as 2 for the equation. So that tells me that our equation y equals mx plus b is going to somehow have to be related to 2. But this is not parallel, this is going to be perpendicular. So the slope that we're claiming for this red line is going to be 2. Now I want to show you another way to verify that before we go on to the blue line any further. Since we already have a picture of the red line using the x-intercept and y-intercept of 2 and negative 4, we could just take a graphical approach here by thinking of the slope as rise over run. So starting at the y-intercept, I would go up 4 and then to the right 2. So that's 4 over 2, which reduces to be 2 over 1, which is just the same as saying 2. So that verifies what we were calculating algebraically for the slope of the red line. Now the slope of the blue line is not going to need to be 2. The slope of the blue line needs to be the negative reciprocal of that. So in other words, it needs to be negative 1/2. Now recall from the definition that there is a way to check and verify that your slopes are going to work and be perpendicular. You're going to take the slope that we were given for the red line, which is 2, and you're going to multiply it by what you think the slope for your blue line needs to be. That'll be negative 1/2. And when you multiply those together, the result is negative 1, which is precisely what the definition says we need to get if in fact these lines are going to be perpendicular. So going back to the equation now, we have y equals negative 1/2 x plus b. The picture again of the blue line is just an estimate, so I cannot use this picture as a means of saying that the y-intercept is going to be at 0, 0. I can't say that because it's just an estimate. So I'm going to algebraically calculate this. I'm going to let x be equal to -6, y will be equal to 4, and then we'll have 4 is equal to -1/2 times 6 plus b. So therefore 4 is equal to -3 plus b. And let me make a correction here. I'm supposed to be plugging in -6, which is going to make this a +3, which means b needs to be +1. So easy to make those little errors there. We corrected it. B is going to be 1, which ultimately means that my equation will be y equals -1/2 x plus 1. Now let's verify this graphically. If I know that the slope is supposed to be -1/2, starting at the point -6, 4, I should be able to go down 1 to the right 2. And if I continue to do that pattern down 1, right 2, I will eventually get to the point at 0, 1, which is that y-intercept. And now I get a much clearer picture of the way that the blue and the red line are supposed to look to guarantee that it's perpendicular. So my initial estimate wasn't terrible, but it also wasn't correct because I shouldn't have been passing through the origin. I should have been passing through 0, 1. And so this blue line does have a much better look to it compared to the original, and now I can see that 90-degree angle is there. So last thing, we're going to do our function definition. So f from r to r by f of x is equal to -1/2 x plus 1.